Assalamu alaikum, dear students. Today, the topic we're going to discuss is sound waves. So, the general definition of sound waves is we know that the sensation felt by our ears is called sound. This is the general definition of sound in daily life. But to be more precise, scientifically speaking, the vibrations that travel through air or any other molecules of any medium and can be heard when they reach a person's or animal's ear is called sound. Okay, sound is basically nothing but the disturbance due to energy in a certain medium. So first, let's see what type of waves are sound waves. Does the sound travel like this in the form of transverse wave, like we all see in the illustrations in our computer? The sound travel like this. Does it travel like this as transverse wave, or does it travel like this in the form of longitudinal waves? Remember that in transverse wave, these are called the trough, and these are the crest. Okay, and what is the wavelength here? This would be the wavelength. But in the case of longitudinal waves, what would be the wavelength and what would be the compression and rarefactions? We see here this part is a little denser than this one, and this one is a little denser than these two, and this one is also dense. These two are less dense. So we see that this part contains more energy than this one because it has more vibration, it has more disturbance than the rest of the other. It has more disturbance than these ones, it has more disturbance than these ones, and these ones have less disturbance than the denser ones. Okay, so here what exactly are we've already discussed that longitudinal waves carry compression and rarefactions, but where are the rarefactions and compressions? These are called compressions, and these are called rarefactions. So the part where the wave is denser is called the compression, and where it's not dense is called the rarefactions. Hope now you get it. Okay, so these sound waves do not just carry the air particles along with them. The air particles just transmit energy to other air particles, which causes the transmission of sound waves. Okay, so suppose these lines are nothing but the rows of air particles. See here, these are closely bound together because they have more energy. They are compressed, they have been applied by more pressure as compared to this part. Okay, so these are the air molecules, and when the energy is transferred to this atom, it transfers this energy to this one, and this one to this one, and this one to this one, and this one to in turn this one. But when it enters this part, we see that there is more distance in atoms than there were in this region. So the loudness of sound will be less here than this part. This part will be louder, this part will be a little quieter because less sound will be transmitted in this part. Okay, same goes for the rest of the wave. Now we see how these waves exactly are generated. What are the conditions that must be satisfied for the production of sound waves? Okay, necessary conditions for the production of sound. The first one is vibrating body. We know that sound is produced by vibrating body, by oscillations. All kind of waves are produced by oscillations or vibrations. When a certain body vibrates, it produces sound. It produces energy that travels through the medium in form of sound. Let's take a tuning fork. You're already familiar with what a tuning fork is. You've seen it in your labs. Take a tuning fork, strike it on a rubber pad. You will see it will start vibrating to and fro. Okay? So what exactly these vibrations do? They produce sound. They produces sound waves. Okay? These when you place your ear just by these tuning forks, you will exactly see some disturbance created by them. You will actually see some fainted sound. Okay, so this is how vibrating body produces sound. Any kind of vibrating body can produce sound. The next condition is transmitting medium. Okay, so I've already told you that the medium is necessary for the transmission of sound waves, because if we don't have any medium, how would any particle transfer energy to the other? Okay, see here, this atom will transmit energy to this one to this one, this one to this one, and in turn the compression area fraction would take place. But if we take vacuum such that there are no air particles in it, and then we vibrate a body which produces sound, but the vibration would definitely take place. But what happened? You won't be able to hear the sound. There would be vibration produced around it by the body, but there won't be any air molecules to carry these vibrations up to your ear. Okay, so you won't be able to hear anything when when a body vibrates in vacuum. So for the production of sound waves, it is necessary that we have a transmitting medium, any kind of medium, but not vacuum. Third one is hearing device. So the most common hearing device is our ear force. In the ear of any living organism, say animals or birds or humans, can hear the sound, can be used as a detector of sound. Here I have draw a sound wave that travels in the form of compressions and rarefactions. Okay, so how would you detect a sound? How would you say there is a sound wave if you do not have a detector at all? So the third one is hearing device, which is without which we cannot actually hear any sound or detect any sound, which is necessary condition for the production of sound. Here, my drawing is not so well, so just ignore the drawing. Okay, this is just um, a human ear. This is the eardrum of the human ear. When these compression and rarefactions fall on our eardrum, what happens? They transfer this energy to our eardrum. They transfer this energy in the form of kinetic energy, because these air molecules vibrate. As they vibrate, they have kinetic energy. As they have kinetic energy, and when they fall on eardrum, they transfer this kinetic energy to this eardrum, which in turn starts to oscillate. When this oscillate, electric signals are then transferred to your brain. Okay, so these are basically the conditions which are necessary for the production of sound. Good day, everyone.